Okay, everybody, we're going to wrap up chapter 3 today. Actually, we're going to talk about residuals and residual plots. So we're going to go and jump right in. Let's go ahead and take a look. Screen. So, okay, this is what we kind of worked about in class. So let's do a quick review. What we're looking at is we talked about last time that when we look at this, that the residuals are actually the vertical distance between the point in the scatter plot and where we would predict it using the LSRL. The sum of the residual plots is always going to be equal to 0 when we do that. That's the whole point of an LSRL. So what's going to happen is imagine we had this curve, if you will. So 2, 1. So we have a point at 2, 1. We have one at 3, 4, 3, 4, 5, 6, 5, 6, 6, 5, 6, 5, 7, 9, 7 and 9, 9 and 8, so 9 and 8, and then 10 and 11, so 10 and top here at 11. So we can see there's definitely a positive association here. So what we're actually going to do is we're going to just do a quick LSRL. So again, I told you that this is not something that's going to come up an awful lot, but I just want to show you how you do it in the calculator. So the way you would do it in the calculator is you would go to stat, you would go to edit, and you put in your X's, your explanatory in L1, so 2, 3, 5, 6, 7, 9, and 10. And then you put in your responses in L2, so in this case, 1, 4, 6, 5, 9, 8, and 11. Okay, so now if we want to look at the scatter plot, we do second y equals. We're going to turn the stat plot on, and what it defaults to is the scatter plot. So we do zoom 9, and that would give us our idea of what our look like, and actually kind of looks like that picture I have. Okay, so now let's take a look and see what the regression equation would be. So I want to go ahead and look at the regression equation here. So what's going to end up happening is the way we do that is we go to stat, calc, we do number 8, lin reg a plus bx. Explanatory in L1, response in L2. Don't worry about frequency list. Again, I want to store it, so I'm going to do alpha, trace, enter to store it. And what's going to happen is it's going to give me the regression equation. And what the regression equation is going to be is that y hat equals a, which is my y-intercept, which is negative 0.06, plus b, which is my slope, 1.058 x. And I would need to define what y and x mean. So that's what it would be. So now, the line, let's go ahead and look at it. So we'll do zoom 9 to look at the line and how it fits the data. So what ends up happening is the residual is the distance between each one of these points in the line. So there's a really quick way to do that. And I can show you actually how you can do that in your calculator. We do stat, edit. And for L3, what I want to do is I actually want to use the regression equation to make the prediction. So I'm going to do alpha, trace, and what I'm going to do is hit enter for Y1. I put in open parentheses. And basically what I want to do is I want to substitute all the X values in. So I'm going to do second 1. And what's going to happen is those are all of my predictions. So those are all what I thought it should be. So when I go to do this, I thought that it was going to be 2.0549. I thought that it was going to be 3.1126. I thought it was going to be 5.228. I said the model should predict 6.2857, 7.3434, 9.4588, 10.516. So those are my predicted values. This is what I actually observed. So if you want to think about it, this is observed, and this is my predictions. So the difference between them is going to be my residuals. So what I'm going to do is I'm going to get the residuals over here. So the way I'm going to do that is second 2 minus second 3. Again, you're not going to have to go into this level of detail, but I'm just showing you where it comes from. So those are all of my residuals. So my residuals are negative 1.055, 0.8874, 0.772, negative 1.286, 1.6566, negative 1.459, 0.4835. And as you notice, negative residuals are where I did an overestimate. Negative residuals are overestimates. Positive residuals are underestimates. Because look, I thought it was going to be 2.05. It actually was 1. What I did is I overstated it. I thought it was going to be 3.11. It actually was 4. I understated it. So positive or understate, negative or overstate. So in this case, what I want to do is I want to look at what that residual plot looks like. So what we're going to do is we're not going to worry about R's right now. We're going to look at this residual plot. And what this residual plot does is it plots all of my X's against my residuals. So what I want is I want my X's to run along the horizontal and my residuals to run along the vertical. So what I'm going to do is this. I'm going to go back to my second y equals stat plot. And what I want to do here is my X's go on the L1, so the horizontal, and I want to put my residuals, which in this case is going to be my L4 list and L2. And quit. And I'm going to do zoom 9. And that's called my residual plot. Okay. What you're looking for in a residual plot is you do not want to see a pattern. So, I mean, you don't want to see like a curved pattern. You don't want to see it constantly increasing, constantly decreasing. You just want to see just a jumble of points. And you want to see those residuals being relatively small in nature. So in this case, this residual plot would demonstrate to me that a line is a good fit for this. Now, all that being said, let me show you an easier way to get a residual plot. The easy way to get a residual plot, instead of doing everything I just did, look at your LSRL. Let me show you a kind of a good estimate of what it would be. Make it horizontal. Make it like it would be a horizontal line. Imagine you have that line of best fit that kind of runs through the middle. That's a good idea of the residual plots. If you look at these two, pretty close. I mean, they're pretty close. This one's scaled a little wider, why the points are a little further away. But that's a good way to look at for a residual plot. And again, the whole point is the residual plot should not show a pattern. Should not show a pattern. So let me show you some examples of residual plots with patterns, and that's how we'll wrap it up. Here's a residual plot that has a pattern. So imagine I had a residual plot and it looked like this. That's a pattern. What it's saying is that for very low values of X, for very, very low values of X, I have positive residuals. I understate. For middle values of X, what I do is I overstate the results on these ones. And then here again, I go back to like I was at the beginning. So notice there's a pattern. So depending on where I make my predictions, let me show you another example of what a pattern would be. This is what this one is called. I'll tell you at the end. So it's right here. So if you look at this, it's kind of like no pattern, right? But imagine all of a sudden it started going like this. And when I started doing this pattern, the further I got out, the worse it got. That's a pattern. And it actually has a name. It's called a trumpet. And the reason it's called the trumpet, think about it, kind of looks like the horn of the trumpet. So that's the kind of thing that would not. So these linear models would not be good predictors. A linear model would not be a good predictor. But going back to this one, there's really no pattern to it. So in this case, a linear model would be a good predictor. So that's basically what we talked about today. And that honestly wraps up the chapter. We'll do a little bit of a review, see some FRQs on Tuesday. And then Thursday of next week, we're going to go ahead and test on chapter 3 and get ready to move on to chapter 4.